Hello everyone, I Deepa Chhetri, bearing roll number 20NS0304 of Physics Department of Namchi Government College, affiliated with Sikkim University. I would like to express my heartfelt gratitude to all the faculties of the Physics Department, especially Dr. C.P. Khatiwara, for giving me this beautiful opportunity to make video on the topic FTIR and UV-VIS spectroscopy. This video is for our sessional B of paper 6. So the topic for the video is FTIR and UV-VIS spectroscopy.
Spectroscopy. Spectroscopy is the study of absorption and emission of light and other radiation by matter. EMR, that is electromagnetic radiation र matter को बीचको interaction को study लाई चाहिँ spectroscopy भनिन्छ. Matter त जे पनि हुन सक्छ like DNA, RNA, protein or any other compound. It is the powerful tool available for the study of atomic and molecular structure, and it is used in analysis of a wide range of samples. There are many types of spectroscopy, but the most common ones are: first, infrared spectroscopy; second, ultraviolet visible spectroscopy; nuclear magnetic resonance spectroscopy; Raman spectroscopy, etc. Principle of spectroscopy. The principle is based on the measurement of spectrum of a sample containing atoms or molecules. Spectrum is a graph of intensity of absorbed or emitted radiation by sample versus frequency. And the spectrometer is an instrument designed to measure the spectrum of a compound. FTIR spectroscopy. FTIR stands for Fourier transform infrared, the preferred method of infrared spectroscopy. FTIR is the preferred method of infrared spectroscopy because FTIR is the updated advanced version of IR. It has more accuracy as compared to IR, though FTIR is also a part of IR. In infrared spectroscopy, IR radiation is passed through a sample. Some of the infrared radiation is absorbed by the sample and some of it is passed through or transmitted. The resulting spectrum represents the molecular absorption and transmission, creating a molecular fingerprint of the sample. Like a fingerprint, which is unique, no two unique molecular structures produce the same infrared spectrum. This makes infrared spectroscopy useful for several types of analysis. So, what information can FTIR provide? First, it can identify unknown materials. Second, it can determine the quality or consistency of a sample. Third, it can determine the amount of component in a mixture. Superiority of FTIR. Fourier transform infrared spectroscopy is preferred over dispersive or filter method of infrared spectral analysis for several reasons. First, it is a non-destructive technique. Second, it can provide a precise measurement method which requires no external calibration. It can increase speed, it can increase sensitivity, it is mechanically simple with only one moving part. Comparison. FTIR lies a dispersive spectrometerसँग compare गर्दा in order to measure an infrared in spectrum, this dispersive spectrometer takes several minutes, but FTIR takes only a few seconds. Theory of FTIR. FTIR spectroscopy was developed to overcome the limitation encountered with dispersive instrument. It is concerned with the vibration of molecules. Each functional group has its own discrete vibrational energy, which can be used to identify a molecule through the combination of all the functional groups. This is the FTIR instrument. This is how it looks. Now moving on to the advantages of FTIR. First of all, in speed. Because of all the frequency are measured simultaneously, most measurements by FTIR are made in a matter of seconds rather than several minutes. Second, sensitivity. Sensitivity is dramatically improved with FTIR for many regions. Now, mechanical simplicity. The moving mirror in the interferometer is the only continuously moving part in the instrument. Thus, there is very little possibility of mechanical breakdown. Internally calibrated. This instrument employs a HGNE laser as an internal wavelength calibration standard. These instruments are self-calibrating and never need to be calibrated by the user. Now we move to the ultraviolet visible spectroscopy. UV-VIS spectrometry or UV-VIS refers to the absorption spectroscopy or reflectance spectroscopy in the part of the ultraviolet and the full adjacent visible region of the electromagnetic spectrum. Being relatively inexpensive and easily implemented, this methodology is widely used in this diverse applied and fundamental applications. The only requirement is that the sample absorbed in the UV-VIS region, that is, be a chromophore absorption spectroscopy is completely fluorescence spectroscopy. Parameter of interest, besides the wavelength of measurement, are absorptions, transmittance or reflectance, and its change with time. Term that is used in UV visible spectroscopy. First, chromophore, the part of the molecule responsible for imparting color, are called as chromophore. Exochrome, the functional group attached to a chromophore which modifies the ability of the chromophore to absorb light, altering the wavelength or intensity of absorption. Theory involved in UV-VIS spectroscopy. When a beam of light falls on the solution or homogeneous medium, a portion of light is reflected from the surface of the media and portion is absorbed within the medium and remaining is transmitted through the medium. Thus, if the intensity of the radiation falling on the media and IR is the amount of radiation reflected and IA is the amount of radiation absorbed and the IAT is the amount of radiation transmitted, then I will be equal to IR plus IA plus IT. Laws involved. Two laws are involved in UV-VIS spectroscopy. Beer's law and Lambert's law. When Beer's law and Lambert's law combine, it becomes Beer-Lambert's law. Beer's law. When a beam of monochromatic light is passed through a homogeneous absorbing medium, the rate of decrease of intensity of radiation with increase in the concentration of the absorbing species is directly proportional to the intensity of the incident radiation. Beer's law मा चाहिँ absorption is directly proportional to the concentration. Lambert's law मा चाहिँ when a beam of monochromatic light is passed through a homogeneous absorbing medium, the rate of decrease of intensity of the radiation with the thickness of absorbing medium is directly proportional to the incident light. Lambert's law मा चाहिँ absorption is directly proportional to the path length. यो Beer's law लाई र Lambert's law लाई combine गर्दाखेरि चाहिँ we get Beer's Lambert law. Instrumentation. First मा हुन्छ source of radiation. यहाँ चाहिँ lamp छ. Then collimating system. त्यहाँदेखि monochromator. त्यहाँदेखि sample हुन्छ. Then detector. Detector ले amplify भएर चाहिँ we read out the result. यो भयो instrumentation of UV-VIS spectroscopy. अब we have application of UV visible spectroscopy. First of all, it is used in the detection of impurities. It is one of the important method to detect impurities in organic solvents. Second, qualitative and quantitative analysis. It is used for characterizing aromatic compounds and conjugated olefins. Third, structure elucidation of organic compounds. The presence or absence of unsaturation, the presence of heteroatoms like S and O or halogens can be determined. To complete this video or the presentation, I have taken reference from International Journal of Science and Research, YouTube, Google website, Wikipedia, Royal Society of Chemistry, etc. To complete this video or the presentation, I have taken reference from International Journal of Science and Research, YouTube, Google, Brainly, etc. Thank you.